You know about JCI valves and actuators, but it's not enough to know about the individual parts. You need to know how they work together to meet the needs of your customers and their unique applications. The part numbers of JCI products have a logic behind them to describe the part and its use. The name uses alphanumeric codes representing information. This is a part number for an actuator. Roll over each number or letter to know what it means. Type of actuator. Describes the series. Spring or non-spring return. Amount of torque. Input control signal. Power requirements. Kind of feedback. The X, meaning not applicable for this part number, is for electrical connections. The second X, meaning not applicable for this part number, is for high speed, which is optional. Let's watch a part number on the left side of the screen populate with information from the grid on the right side of the screen. Now let's take a look at the logic behind the names for valves. Roll over each number or letter to know what it represents. Valve. Product family. Body type and flow characteristics. End connection. Trim material. Size and maximum CV. Let's watch a part number on the left side of the screen populate with information from the grid on the right side of the screen. Now that you know the nomenclature, you'll use that to help you select the correct valve and actuator combination for your job. Ask yourself the following questions. What's required from the valve for this application? Is it a two-way or a three-way? What is the connection type? What type of medium? What is the pressure drop and flow rate? CV required and pipe connection size? With the right valve identified, you can focus on the actuator. What's the application? Air or water? Spring return or non-spring return? What's the required torque? What's the input control signal? What are the power requirements? What kind of feedback? Here's a scenario for selecting an actuator. We'll go through the scenario, then the answers will populate to show us what the part number will be. We are retrofitting a large air handler where we need new electric actuators to replace an old pneumatic system. This air handler has damper dimensions for return air, outside air, mixed air, which are 52 inches wide and 44 inches long. What is the application? M for damper actuator. The series number is 9. Spring return or non-spring return? Spring return, due to the application having outside air. You do not want the damper actuator to lose power and keep the damper open in the middle of winter. Amount of torque? The equation to figure torque for this scenario is 52 times 44 equals 2,288 square inches. 2,288 divided by 144 equals 15.89 square feet. 15.89 times 6 inch-pounds per square foot equals 95 inch-pounds minimum. As you can see from the note, not all inch-pound measurements are available for each actuator type. In this case, for M92, we can only choose from 27 inch-pounds, 70 inch-pounds, and 177 inch-pounds. You will want to go to the closest number which is larger than the number you're looking for. In this case, 177 inch-pounds. Input control signal. Because of the applications, it is proportional control. Power requirements. Proportional control requires 24 VAC. Kind of feedback. End switches to make sure the damper is in open for fan control. Electrical connection. 3, because the part number begins with M9220. Let's go through another actuator scenario. Here we're installing a zoning system in a new building. We need actuators to control the zone dampers. We need the Johnson Controls VD1600 control dampers. The size of the dampers we need is 18 inches wide and 24 inches long. What is the type of application? M for damper actuator. The series number is 9. Spring return or non-spring return? It's non-spring return due to the application. It's okay for the damper to remain open if the power is lost. What is the amount of torque? 18 times 24 equals 432. 432 divided by 144 equals 3. 3 times 5.5 inch-pounds per square foot equals 16.5, which is 4 nm-35 inch-pounds. What is the input control signal? It's proportional in order to get the right airflow into the room. What are the power requirements? 24 VAC. VAC is for M9104. What kind of feedback? No switch, as feedback is not needed. What is the electrical connection? 2S because it's M9104. And it's not high speed. Now let's select a valve and the actuator for that valve. Our scenario is that we're installing a VAV box in a new building. We need the control valve for the VAV box hot water coil. The coil requires 14 GPM at 5 psi pressure drop. The valve should be selected to provide 14 GPM with a pressure drop across the valve, which is between 5 and 10 psi, which is 1 to 2 times at the pressure drop across the coil at the required flow. What is the valve? VG, which is the only option. What is the product family? Forged brass ball valve, which is the standard for a VAV box. What is the body type and flow characteristics? It's a two-way valve. The three-way valves start with VG18. What is the end connection? Threaded. Most of the time it will be threaded. What is the trim material? It's a stainless steel ball and stem. A stainless steel distributor is most likely to have this. It can be used with steam, hot water, or chilled water. What is the size and maximum CV? This is AG because a half-inch 4.7 CV valve will provide 14.1 GPM at a pressure drop across the valve of 9 psi. This valve should be selected as this valve will provide the needed flow with a pressure drop between 1 and 2 times the pressure drop across the coil at the required flow. Here is a chart which shows cross-section of data. Is there an actuator mounting number? In this case, yes. The number is 9T4GGA. Now we'll choose the actuator for that valve. What is the type of actuator? VA, because it is a valve actuator. The series is 9. Spring return or non-spring return? It's non-spring return, as it is okay for the valve to remain open if the power is lost. What is the amount of torque? Half to 1 inch VG1000s require the M9104 model, which is 35 inch-pounds. What is the input control signal? It's proportional in order to get the right water flow in the coil. What are the power requirements? Proportional control requires 24 VAC. What is the kind of feedback? Feedback is not needed. What is the electrical connection? 2S because it's an M9104 model. Now let's talk about some common applications. The combination of Johnson Controls ball valves and actuators can apply to almost any application you come across. Here are some combinations you may encounter. Click each tab to play a video on that subject to learn more.
In this video, we will be demonstrating the conversion of a Johnson Controls M9310 direct mount actuator from a damper shaft application to a valve application. We'll be utilizing the M9310-500 conversion kit, which contains one pointer lever, one linkage, and two mounting screws. Tools required will be just a T20 Torx driver. First step is to turn the actuator over and remove the coupler. To do this, you'll pull on the release tab and then pull the coupler out. Next, we'll insert the new pointer lever. In order to align the pointer correctly, you want to line up the snaps on the pointer shaft with the flats on the inside of the actuator. Align the new lever with the flats and insert from above. Next, we'll be connecting the new linkage to the bottom of the actuator. The pointy side of the linkage will face down towards the anti-rotation slot on the actuator. After sliding the new linkage over the shaft of the kit, we'll be securing it with the two screws using the T20 Torx driver. You'll want to test that the actuator can rotate without binding. To do this, firmly press the clutch release button and rotate the actuator back and forth. And that completes the conversion. For more information, please visit the website displayed on your screen, and thank you for watching. In this video, we'll be demonstrating the attachment of a Johnson Controls 9310 direct mount actuator to a VG1000 ball valve. We have a 3-way and a 2-way VG1000 ball valve that we'll be demonstrating. The only tool required is just one T20 Torx driver. In order to mount the actuator to the VG1000 3-way ball valve, you will need to pay attention to the starting position of the valve. The starting position can be determined by the indexing marks on the top of the valve stem, which displays the different passageways in the ball. In this instance, this valve is in the full open position. That is, the A port and C port are open and the bypass port is closed. With the valve fully open, we'll want to start with the actuator in the full counterclockwise position. To adjust the position, we'll firmly press the release button and rotate the actuator to the full counterclockwise end stop. Next, we'll place the actuator onto the mounting flange of the valve, orienting the anti-rotation tab of the actuator towards the C port of the 3-way VG1000 ball valve. To secure the actuator, we'll tighten the Torx screw to the recommended 8 to 12 inch-pounds of torque and check for binding. Next, we'll demonstrate the installation of the actuator onto a 2-way VG1000 ball valve. This is done the same way as the 3-way valve, with only the indexing marks on the valve stem being different. They are a straight line, mirroring the straight hole that is through the ball in the valve. This valve is full open, so we'll want to orient the actuator with the anti-rotation slot towards the B port on the VG1000 ball valve. Tighten the Torx screw to the recommended 8 to 12 inch-pounds of torque and check for binding. Check that the 4 anti-rotation posts have fully engaged in the holes of the valve mounting flange. And this completes the installation. For more information, please visit the website displayed on your screen, and thank you for watching. In this video, we'll be demonstrating the installation of a Johnson Controls direct mount 9310 actuator onto a VG1000 three-way ball valve. We'll be utilizing an M9000-561 thermal barrier kit. The tools required for this are one T20 Torx driver and one 11 32 inch wrench. The contents of the kit are one thermal barrier linkage, one drive shaft, 4 mounting screws, and 4 nuts. The first step will be to attach the drive shaft to the thermal barrier. There's a keyway on the drive shaft that you want to align with the keyway on the thermal barrier. Insert the drive shaft from the bottom side of the thermal barrier while aligning the keyway. Rotate it 90 degrees clockwise to lock it in place. Next, we'll mount the thermal barrier to the VG1000 ball valve, aligning the indexing marks on the thermal barrier drive shaft with the indexing marks on the VG1000 valve stem. Next, we'll be securing the thermal barrier using the 4 mounting screws and nuts. Insert the screws from above, allowing them to protrude through the holes in the valve mounting flange. Using your T20 Torx driver, hold the screws and start the 4 nuts. The thermal barrier is used for fluid temperatures up to 284 degrees Fahrenheit or 15 psi saturated steam, and it allows for extra clearance when using insulation. Using a wrench and a T20 Torx driver, tighten the 4 screws and nuts to 21 to 25 inch-pounds. Next, attach the actuator to the VG1000 ball valve thermal barrier assembly by orienting the anti-rotation slot of the actuator towards the C port of the VG1000 ball valve when the valve is in the full open position. Place the actuator on top of the thermal barrier and engage the drive shaft with the drive shaft of the actuator. Secure the actuator by tightening the T20 Torx screw to 8 to 12 inch-pounds. Check for binding. And that completes the installation. For more information, please visit the website displayed on your screen, and thank you for watching. In this video, we'll be talking about wiring a Johnson Controls M9310-HGA direct mount actuator. The HGA actuator can be wired for on-off control, floating control, or proportional control. For on-off control, the black wire is your common wire, the red wire is your powered on signal or counterclockwise rotation, the gray wire is your powered off control wire or clockwise rotation, and finally the orange wire is your 0 to 10 volt DC feedback signal. For floating control, your black wire again is your common, your red wire is your counterclockwise rotation, your gray wire is your clockwise rotation, and your orange wire is your 0 to 10 volt DC feedback signal. For proportional control, again, the black wire is your common. The red wire is your 24 volt AC/DC power. The gray wire is your control signal, and the orange wire is your 0 to 10 volt DC feedback signal. For further information, please see the wiring diagram attached to the wire or refer to the installation instructions. Please visit the website displayed on your screen. Thank you for watching. This video will be demonstrating the installation of a Johnson Controls 9310 direct mount actuator onto a VG1000 three-way ball valve and a M9000-342 weather shield enclosure kit. To do this, you will need a Phillips screwdriver, a T20 Torx driver, two 11/32 inch wrenches, two 7/8 inch open end wrenches, or two adjustable wrenches. The first step is going to be to remove the weather shield enclosure cover, loosening the 4 screws, one on each corner, but don't remove them completely. Remove the cover and set it aside. Remove the packaging material from inside the enclosure. Unpack and inventory the kit. The M9000-342 weather shield enclosure kit contains the enclosure cover, the mounting bracket with bearing, the mounting plates, 2 cable clamps with nuts, 1 shaft and a protective pocket, a thermal spacer, 1 plug, 3 self-tapping screws, and we have 4 screws and nuts for assembling the enclosure and 4 screws and nuts for attaching it to the valve. First, we'll be taking the valve and installing the thermal spacer over it. Next, we'll install the mounting bracket on top of it with these 4 screws and nuts. Temporarily install the shaft, which will help keep the bracket aligned. Tighten the screws and nuts to a recommended torque of 35 to 44 inch-pounds. Next, we'll want to install the mounting plate. Now this has 2 indented features on the plate that will align into the holes on the mounting bracket. Ensure you align the plate onto the mounting bracket before you proceed with the next step. Take the 3 self-tapping screws and get them aligned. They will not appear straight at first, but they'll self-tap anyway. Tighten the screws to a recommended torque of 31 to 40 inch-pounds. Next, we'll want to align the marks on the top of the shaft with the marks on the valve stem and install the shaft. Install the weather shield base and seal assembly on the weather shield enclosure mounting bracket. Secure using the 4 number 6 half-inch screws and nuts in each corner using the Phillips head screwdriver and 11/32 inch wrench. Tighten the screws to a recommended torque of 9 to 12 inch-pounds. Next, we're going to secure the strain relief conduit adapters. Simply insert the conduit adapter into the left side hole and tighten the nut on the threads from inside the enclosure. Make sure that it is a snug fit. Feed the electrical cables through the strain relief conduit adapter. Loosen the adapter to make feeding the cable through easier. Position the actuator onto the internal bracket, aligning the 4 studs with the holes in the bracket and positioning the actuator with the anti-rotation slot towards the rear of the enclosure. Using the Torx driver, tighten the actuator screw to 8 to 12 inch-pounds. Make sure that the actuator is able to move without binding by firmly depressing the release button and rotating it back and forth. Also check that it is snug in place. Since there is no cord coming out of the other port, we're going to want to plug this other hole. So we're going to take this plug and install it to the bottom. The ring nut will go on the inside of the enclosure. Tighten the plug to a snug fit. It's okay if you have one extra cable clamp left over, which can be used if you have end switches or for other applications where you have other wires coming out of the enclosure. Now we will install the cover the same way that it came packaged. Tighten the 4 corner screws to 9 to 12 inch-pounds. The final step is this cable gland needs to be tightened to create a water-resistant seal. This completes the installation. For more information, please visit the website displayed on your screen, and thank you for watching.
Click each part number to learn more about it. M9000-551, ball valve linkage for non-spring return, half to 1 inch hot chilled water applications. Compatible actuator or actuators are listed. M9000-561, thermal barrier for M9000-551 and M9000-560. Ball valve linkage permits use of M or VA9 actuators on VG1000 valves with low pressure steam. Compatible actuator or actuators are listed. M9104-100, conduit adapter for 3/8 inch flexible metal conduit for use with M9102 and M9104 with 2S actuators with an integrated wiring harness only. Compatible actuator or actuators are listed. M9200-560, ball valve linkage for non-spring return, half to 1 inch hot or chilled water applications. Compatible actuator or actuators are listed. M9200-100, threaded conduit adapters for half-inch electrician's fittings. Compatible actuator or actuators are listed. M9000-400, jack shaft mounting kit, half to 1.05 inch. Compatible actuator or actuators are listed. M9000-340, Weather Shield NEMA 3R, VG1000 series ball valves with M9000-517 or M9000-519 linkage. Spring return. Compatible actuator or actuators are listed. M9000-322 NEMA 4X, IP66 or 67, Weather Shield Kit for damper application of M9104, M9310, M9203, and M9208 series electric actuators. Compatible actuator or actuators are listed. M9310-500, ball valve linkage with manual lever for M9310 and VA9310. Compatible actuator or actuators are listed. M9300-1, external auxiliary switch kit 1XSDPT. Compatible actuator or actuators are listed. M9300-2, external auxiliary switch kit 2XSDPT. Compatible actuator or actuators are listed. Now it's time for a knowledge check. There will be no audio during the knowledge check. Good luck! Congratulations, you have completed the module.